Welcome to my channel. My name is Simon Apadaka. Today we are looking at logistic regression in finance and accounting research. I remain your host, Simon Apadaka. You can reach me on my phone as is shown on the screen, or on my email if you need any statistical research assistance in finance and accounting. Thank you. Logistics regression. What is logistic regression? Basically, logistic regression is a statistical method used to model binary outcome. When we are talking of binary outcome, we are meaning the outcomes are two. It's either you fail or you pass, either positive or negative. Either a firm is bankrupt or it's not bankrupt. Or it could be a firm is paying dividend or not paying dividend. Those are some examples we can think of when we talk of a binary outcome in accounting and finance research. This statistical method is useful to us as researcher because it helps us to understand the influence of key financial and non-financial variable on decision making. It is actually applicable in situation whereby, one, logistic regression is applicable when the outcome variable is binary, like I've said earlier, such as when we talk about outcome variable, we are referring to actually the dependent variable. So when your DV is a yes or no, success or failure, pay dividends or not pay dividends. In such case, the best statistical method to use is logistic regression. It is used in accounting and finance to study events like the likelihood of dividend payment, as we shall see in this video. We will use Stata to explain, to model the likelihood of dividend payments. It is suitable for understanding the influence of multiple predictors, such as profitability, institutional ownership on decision making. In this case, we will be looking at the influence of profitability, institutional ownership, and firm size, and among other variables, on the decision whether to pay dividend or not. It is especially relevant when predictors are a mix of continuous variable and categorical variable. Continuous variable like return on assets and Tobin Q, and you have a categorical variable like sectorial classification. So we'll be moving into the Stata environment shortly, and we'll be looking at the likelihood of dividend payment. And like we said, we want to know the decision to pay or not to pay dividend. So the dividend payout will actually be dichotomized by, we will carry out a binary transformation such that firms that are paying dividends will be assigned the value of 1, and firms that are not paying dividends will be assigned the value of 0. The Stata command to do this is as highlighted on the screen. Generate dividend per share underscore binary is equals to dividend per share greater than 0, and you can generate a label to label the ones that are no dividends as 0, and the one that pay dividend as 1. The objective here is to model the likelihood of a firm paying dividends based on firm specific characteristics. So we're in the Stata environment now. These are the firms we are looking at: Vitafoam, Unilever, Nigerian Northern Flour Cement, and the rest of them. There are about there are 160 observations here. That's the data set. We will now use. We'll go in, we'll go into the do file that we're going to use to run this. Let me quickly explain the do files that I've already created, so that we'll know what we are doing. Yes, these are the command lines that I've generated in Stata. Logistic regression analysis do file. The first instruction there is just to clear the screen, and the first, the one on line 6 is what I explained earlier. We needed to generate the binary outcome variable for dividend payout, and that's the command. After that, we have the summary. Summary statistics. We are given a summary of the variables of interest that we are looking at. After that, we have the correlation matrix that we will run. The command for the correlation matrix is as shown on the screen. Next, we'll now run the logistics regression, which is logit DPS underscore binary Tobin Q institutional ownership ROA equity to debt ratio and firm size. Thereafter, we'll run the odd ratio. Odd ratio is an extension of the logistics regression. You will see the odds of dividend payments as we run it in logistics regression. I think those are the ones we'll need to run. Then we can have a list of or the variables that shows the firm that have the chance of it has the probability of paying dividend that is greater than 0.5, and we'll have a list of such firms. It will give us an idea of firms that are likely to pay dividends with their probability greater than 0.5. That said, we'll move into the Stata environment again. Now we are ready to run the analysis in Stata environment. Like I said, the first line is just the first 3 lines is used to clear our screen, and we'll then the 5th to 6th to generate the binary variable. We'll dichotomize the dividend payment into dividend paying firms and non-dividend paying firms. So without much ado, we'll run this do file in Stata environment. I've selected all, and I'm clicking on execute selections. Yes, we have successfully run our do file command. Now the first the binary variable has been generated and is as shown in the summary statistics. You can see that dividend payout binary has 160 observation, and it has a mean value of 0.8 and a minimum value of 0 and maximum value of 1, obviously, because it's a binary outcome. So the minimum and the maximum will hover around 0 and 1. So the mean value tells us that about 80% of 80% of the firms in this observation, 80% of the firm in this observation actually pays dividend, while 20% are not paying dividends. The statistics for Tobin skew, which represents firm value, is also stated. You can see the minimum value is 0.4, whereas the maximum value is 9.4. Tobin's measure the value of a firm. Institutional ownership ranges from 9% to 95%, and so also with others. Now, the distribution of the binary outcome, that's the dependent variable, like I stated earlier, is 20% of the firm are not paying dividends, while 80% are dividend paying. The correlation matrix is as shown here. You can see that Tobin's skew is positively correlated with the binary outcome. That's a dividend binary, the likelihood of a dividend. Whereas institutional ownership is negatively correlated. ROA is positively correlated. Equity to debt ratio is negatively correlated. Firm size, looking strongly, is also positively correlated with the dependent variable, which is the binary dividend payout. The logistic regression is run, and the result is as we have it. The number of observation is 160, and the R square is the pseudo R square is 37%, which mimic the way we interpret the multiple regression analysis. We can say roughly that this explains about 37.4% of the variable that determines the likelihood of dividend payments. The chi-square is highly significant, showing that our model is well fitted for this analysis. So the result of the binary logistics is as we have it here. Tobin's is negative, has a negative influence on the dependent variable, but it is not statistically significant. Institutional ownership also has negative effect, and it is highly significant at 1% level. ROA is positive but not statistically significant. Equity to debt ratio is negative, and it is not statistically significant. Firm size is positive and highly significant at 1% level of significance. So that is how to actually interpret the binary logistics regression. You can take the result further if you are very much familiar with ChatGPT environment. You can actually ask Chat to interpret this result for you. I copy this and I go into interpret these results. Let's see what ChatGPT will do with our result, though I have not actually defined my variable acronyms. but let's see what it does with it. So number of observation, 160 firm likelihood, log likelihood is minus 50.088, indicating how well the model fits. Like I explained earlier, our chi-square is highly significant, and meaning the independent variable collectively explain the variation in the dividend or the binary dividend payout. The pseudo R square, which is 34%, indicates that about 37%, about 37.44% of the variation in the dependent variable is explained by independent variable, like I earlier explained. And these are the interpretation of the coefficients of the explanatory or predictor variables. Like the Tobin skew is there, it is not statistically significant. Institutional ownership is statistically significant. ROA is not statistically significant. Debt to equity ratio, fine, you got it right. It is also not statistically significant. Firm size is highly significant. The p-value is 0.000, and the coefficient is 2.4. So interpretation is that larger firms are more likely to pay dividends, and a 1 unit increase in firm size increases the log in firm size, that's log transform, increases the log odds of paying dividends by 2.427. So for 1 unit increase in firm size as log transform increases the log odds of paying a dividend by 2.4%. That is good. It means that big firm, large firms, they have high chances of paying dividend in the consumer goods sector. So, in summary, significant predictors are institutional ownership, which is highly significant at 1% level. It has negative coefficients. That means the impacts, the more institutional ownership present, the less likely a firm is likely to pay dividends. It says institutional ownership with a p-value of 0.003 negatively affect dividend payment, and firm size with a p-value of 0.00 positively affect dividends. The non-significant predictors are what you see. Implications of this is chart interpretation. Institutional ownership may prefer firms to retain earnings rather than distribute dividends. That is, in the consumer goods sector, it is likely that where you have high level of institutional ownership, they are less likely to pay dividends. Large firms are more capable of paying dividends according to, because the size is highly significant. Large firms are more likely to pay dividends, potentially due to greater financial stability and profitability. The insignificant influence of a Tobin skew, ROA, and equity to debt ratio suggests that these factors may not be the primary determinant of dividend policy in this sample or in this context. Further investigation could focus on sectoral effects or interaction effects to refine the models. So that is how ChatGPT gave us a further insight into the analysis, the regression analysis we ran. You record also that I said we are going to, you can take the interpretation further by also, running the logistic regression with the odd ratio, that's OR with the odd ratio, and this is the results for the odd ratio. This is the result for the odd ratio. We can also quickly check the interpretation for the odd, for this one, this second regression with the odd ratio. So chart will also give us a quick interpretation of the odd ratio. So the odd ratio provides an intuitive way to interpret the impact of independent variable on the likelihood of the dependent variable being one, that is the firm paying dividend. Here is the interpretation of the results. That's the pseudo R square, which we have already interpreted earlier, the likelihood ratio, which is highly significant, confirming that the model as a whole is valid. The odd ratios and interpretation. For Tobin's Q, the odd ratio is 0.976, but the p-value is not significant. It's not significant. Interpretation: for every 1 unit increase in Tobin's Q, the odds of a firm paying dividends decreases by 2.4%. Decreases by 2.4%. That is 1 minus 0.976. That's the odd ratio. That's the odd ratio that we have here. So it decreases, but it is not statistically significant. This suggests that Tobin's Q has no meaningful effect on the likelihood of dividend payment in this context. For institutional ownership, the odd ratio is 0.948. So with a p-value that is significant at 1%, so interpretation is that a 1 unit increase in institutional ownership reduces the odds of a firm paying dividends by 5.2%, which is derived from 1 minus 0.9448. That's the odd ratio. So the implication: institutional ownership has a significant negative impact on the likelihood of dividend payment in the consumer goods sector. Return on asset, ROA, has a odd ratio of 1.027 with a p-value that is not statistically significant of 0.51. Interpretation: a 1 unit increase in ROA increases the odd of paying dividend by 2.7%. 2.7%. But this effect is not statistically significant. Profitability does not meaningfully impact dividends likelihood in this model. We have the debt to equity ratio with a odd ratio of 0.895 and a p-value that is not statistically significant. Similarly, 1 unit increase in equity debt ratio reduces the odd of paying dividend by 10.5%. 10.5%. So that is how it goes. But this is not statistically significant. Leverage does not significantly influence the likelihood of dividend payment. For firm size with odd ratio of 11.352 and a p-value of 0.000, which means it's highly significant. Interpretation is that 1 unit increase in firm size, that's log transform, the odd of paying dividends are 11.35 times higher. This is huge, meaning that large firms have strong and large firms are more likely to pay dividends. This highlights a strong and significant positive relationship between firm size and dividend payment likelihood. So the constance is there, and the interpretation without much ado. Key takeaway: firm size is highly significant, is positive, and highly significant, as large firms are more likely to pay dividends as their odd increases exponentially with size. Institutional ownership, which is negative and significant. Institutional ownership reduces the odds of paying dividends, reflecting the potential preference for such owners for earnings retention. The other predictors are not significant. We have Tobin's Q, ROA, EDR. They are not statistically significant. Practical implication: policy aimed at enhancing dividend payments should focus on encouraging smaller firms to grow. Institutional ownership negative impact may indicate a need to align dividend policy with the preference of such investors. The odd ratio format effectively communicates the magnitudes and the direction of effect, making it easier for practitioners to apply the results. So that is a wonderful interpretation that the ChatGPT has given to this our statistical analysis. So with this, I will come to the end of today's video. I think it's quite interesting to have this session. We have talked about the likelihood of dividend payment using the logistic binary regression. I hope you enjoyed it. If you do, please like, share, and subscribe.